So this is one of two before we start videos. So welcome. We're going to talk about functions. We're going to talk about functions in this video, and we're going to talk about functions in the next video. The subject today is what are functions? And so what are functions? And we'll start here with the definition you might tell a kid. I like to talk about this definition at the start of every class because it makes a nice picture. A function is like a conveyor belt, right, that takes some raw materials and sends them into this machine. Right? It goes inside the big function machine and it clangs around in there. And then it comes out, right, as a finished product. So, you have this big machine and it takes in, a slab of metal, and then it comes in and it bangs around in there, and out come 1,000 spoons. And so a function is just that. It's some process that takes inputs and gives you outputs. And so, that's, again, if somebody says, hey, what's a function? You can tell them this, and then they'll look at you crazy and walk away. So there's a couple of ways to represent a function, right? More often than not, the way we represent a function is by using an equation. So you can see in the very center of this slide, we are having functions like f of x equals 3x squared minus 5, g of x equals x sine x, h of x is the fourth root of 10 minus x, and so on. There's a lot of functions. We'll never run out of functions. When we write f of x, f is the name of the function, and x is the input. Okay? So remember that when you see f of x, when you see those parentheses, the parentheses don't mean multiplication. This is not ever f times x. That's not what that means. What it means is that it's f of x, x is the input, and x is being put into f, the name of the function. So the reason why functions have names is so we can talk about them. Right? We can ask questions like, when does f increase? How many roots does f have? Does f have a maximum? Does f have a minimum? Does f have an asymptote? Is it continuous? Right? We give them names so we can talk about them. The reason functions have inputs, one, is so we can plug in values, right? So back here in f of x equals 3x squared minus 5, maybe we want x to be the number 2. And so we write f of 2, and then we replace every x with 2. That's one way to do it. And the other reason is, and we're going to do this a lot in calculus, is that we want to, instead of writing f of x, we want to write f of a bunch of stuff. F of 2 minus x, f of 1 over x squared, f of x. Oh my god. We can just plug anything in where x used to be, and something happens. You should pause this slide, and you should think about, for each of those three boxes, why I replaced things the way I did. So if you're done pausing the video and you understand what's going on, we can move forward. Function party, or what we call composition, right? If you have a whole bunch of functions, you can combine them in an interesting way. And the way you can combine them is with what we call composition, right? So suppose you have two functions, f and g, and you write f of g of x. The way you read this is that x goes into g first, and then that answer goes into f, right? So in terms of the function machine, g comes before f on the conveyor belt. X goes along, goes into the g box, comes out as g of x, and then g of x goes into the f box. And so down below, I wrote two functions, 3 minus x and x squared, f and g, and I wrote how to compose, right, with just two compositions, f of g, g of f of f, and g of g. So go ahead, again, pause the video, convince yourself that the stuff on the bottom makes sense, and when you believe it, move on. All right, so the other way we're going to represent functions a lot during the semester is we are going to represent them as a graph, right? Sometimes you have a function and you graph it, but sometimes you can just start with a graph of a function, right? Here's a graph. The graph defines a function. So over there in the upper right-hand corner, there's a picture. The picture is a graph of a function called f of x. And two values, an x value and a y value, combine to give you a point on the graph. Right? X comma y is on the graph of f of x only if whatever the y value is f of x. And that's in that box in the lower left-hand corner. To be on a graph, right, for x, y to be on a graph, y has to be the same thing as f of x. This property is super important. You have to know it. You can do really cool things with it. You can do a lot of math without doing any math if you know this property. So we talked about composition. What does composition look like? And so here I drew two different graphs. One graph on the left, the orange graph, is g of x, and the blue graph on the right is f of x. And so what does composition look like? So what is f of g of 5? The left graph is the g of x graph, and so 5 first comes into existence and gets plugged into g. So we plug 5 into g, we go up to the graph, and g of 5 is 2. And so what we do then is we take 2 and we trace along the line going over to the other graph, and we plug it into the graph of f of x, right? Because we want to plug in g of 5 into f of x, and g of 5 is 2, so we plug 2 in and we get 1. So f of g of 5 is 1. So that's kind of what composition looks like. You go from one graph to the other using the output as the next input. So, inverses. We talk about functions. We're going to deal a lot with composition this semester. We're also going to deal a lot with inverses this semester. So what's the story with inverses, right? Inverses are going backwards. If you have a function, sometimes you want to know the backwards version of that function. You want to know how to go back, right? So again, you have a friend, and your friend is German, and so they think in Celsius. And you're like, whoa, buddy, I don't understand Celsius. Why don't you speak my language of Fahrenheit? And he's like, okay, here, I'll write down an equation for you. This equation will let me speak in Celsius, and you can understand it. So you say, okay, that's fine. And so, your friend calls you up and he says, it's very hot. It's 29 degrees Celsius. And then you say, oh yeah, that is very hot, because you convert it. You want to tell him that it's very hot, but if you tell him that it's 90 out, he's going to think that you're probably on fire. So you want to figure out how to convert it so he understands it. The problem is you only know one way to do it, from him to you. So you want to switch it around, and you could just start plugging in numbers, hoping to get 90, right? You plug in 20, it doesn't work. You plug in 21, it doesn't work. You keep plugging in numbers, and it never seems to work out. What you need is the inverse function. You need the one to go from Fahrenheit to Celsius, right? And so the way to do it is to have an inverse. And so on here I have some facts about inverses. One is, if the name of the original function is f of x, the way you write the inverse is by putting a little -1 in the sky next to the letter f. That symbol is f inverse of x. If the domain of the original function becomes the range of the inverse function, and the range of the original function becomes the domain of the other function, they switch. So if you couldn't plug in 6 to f of x, you can't get 6 out of f inverse of x. And if you couldn't get 3 from f of x, if f of x is never 3, then you'll never be able to plug 3 in to f inverse of x. And the way you go from the original to the inverse in terms of the graph is you switch the x and y values. Graphically, what that does is it flips the graph over the y equals x line. And the definition of an inverse is that f inverse of b equals a is the same thing as, that double-headed arrow means is the same as, f of a equals b. And that's it. Those are the things we wanted to talk about with functions. So go over the video, think about it a little bit. This is just to make sure you're up to speed for the start of the class. If you have any questions, please post them online or talk about them in class. And that's it. I'll see you in class.